F is placed on the block system below and accelerates it at 3 meters per second squared, how many times greater is the tension at point 2 than at point 1? A 1.2, B 1.8, C 2.2, D 2.4. Difficulty 2 question. Alright, let me just get settled up here. Let's see. So this is just going back to your basic understanding of physics, and your physics 1 class, probably the first week you covered a problem like this. So hopefully it isn't too bad for you. Let's look at Newton's second law. I think that's just by the looks of this, I see acceleration, I see force, I see tension. I'm automatically thinking this has something to do with Newton's second law, and I notice that I'm not caring about the normal force or really any other forces. I'm just looking at tension here, and I can figure that out pretty easily by using the net force in the x direction. If I call this my x-axis and this my y-axis. So the F net force in the x direction for these two different points I'm looking at point 1 here, and I'm looking at point 2 over here. So let's call this F net x of point 1. And this is going to equal, if we remember Newton's second law, is mass times acceleration. Mass times acceleration. And I already know the acceleration is given as a constant here. It's 3 meters per second squared. So I know that. And the mass, if I think about this is almost like me, the force is going in this direction, and in a rope, this is where the tension is going to lie. It's inside of this rope right here. We can assume this is a rope, even though it's rather abstract, but we can assume this is a rope, and we can picture a character pulling on this rope. It's pulling in this direction, and looking at the first point, well, if you remember, the tension in this part of the rope is going to be a lot less tension than on the end of the rope from where I'm pulling from. And the reason for that is the mass behind here is significantly less. The only mass that is being accelerated from this rope, the tension in this rope, is this 10 kilograms. So when I plug 10 kilograms in for my mass, this is going to result with 30 newtons as the net force in the x direction of my first component. My second component, we'll do it in a different color so I don't get confused, net x component of the second point that we're given. And this is the same thing. This is just going to be mass times acceleration, right? And we want to find what this force is going to be. Well, remember, now we're looking at the second point, which would include everything behind it, going all the way back here, all the way around. So this is our whole system that we're looking at this point, because this tension is going to be affected by all of the counterparts here. So our mass ends up being, if we add all this up, it becomes 24 kilograms. We remember that our acceleration was constant, 3 meters per second squared for both systems. And this ends up coming to, let's see, 72 newtons, it looks like. So if I look at the question again, I'm looking at how many times greater as tension in point 2 than point 1. I know that it's going to be a ratio of 0.2 over 0.1. And when I do some simple math of 72 over 30, I should get 2.4. And that is answer D here. So not incredibly difficult, but we did require some classical Newtonian mechanics here in this problem.